For this video, we're going to continue talking about triangles, and we're going to look more into congruent triangles. We talked about congruent and how it's when two geometric figures have exactly the same size, right? Congruent means same shape, same size. Even if they're off by a very little bit, it means they're not congruent. Okay, they have to be the exact same shape, the exact same size. A couple properties of triangle congruence. First, we have the reflexive property. This will be the one that we probably use the most, and all it says is that triangle ABC is congruent to itself. Right? So when something is congruent to itself, that's the reflexive property. A way that we'll probably see it more is if I have two triangles that share a side. Right? So if I have A, B, C, D. Right? This BC side, it's in both triangles. Right? So I could say that BC is congruent to BC, and that means that that side of the triangle is congruent on both triangles. Okay, so that's where we'll see it the most, is if we say something is congruent to itself, usually when triangles are sharing an edge. Right? Another property is a symmetric property, and that just says that if ABC is congruent to EFG, then EFG is congruent to ABC. Right? It works both ways. And the third is transitive. Right? Transitive means if ABC is congruent to EFG and EFG is congruent to JKL, then ABC must be congruent to JKL. Right? Because if they're all congruent to each other, ABC's got to be congruent to JKL. Right? Another theorem we have is the corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent triangles are congruent. That's kind of a long thing to say, so we have a nice tongue twister for us to use. CPCTC, right? It's much shorter, and it's easier to write, and it's a lot smaller to fit on your paper. So we'll call it CPCTC. Okay, and it just says that polygons are congruent, and we have this IFF, right? IFF means if and only if. Right? Polygons are congruent if and only if corresponding parts are congruent. That if and only if means it has to work both ways. So one way of saying it is polygons are congruent if corresponding parts are congruent. And the other way is corresponding parts are congruent if the polygons are congruent. Right? And corresponding just means the matching parts of each triangle. So if we look at ABC and DEF, I'm told that triangle ABC is congruent to triangle DEF. One thing to keep in mind, this is called a congruent statement, right? I'm told that triangle ABC is congruent to triangle DEF. Okay, it's in order, and order does matter. Okay, if it's telling me this, that means that A corresponds to D, B corresponds to E, C corresponds to F. Right? So that means AB corresponds to DE, BC to EF, and AC to DF. Okay, so it's all corresponding in the way you write it. Order does matter. So looking here, that means that angle A must be congruent to angle D. Well, if we look at our triangles, I have a yellow-orange color for A here, a yellow-orange color for D here, just further adding that they're congruent. Okay, I also know that angle B must be congruent to angle E. In our pictures, they have those labeled red. And I also know angle C must be congruent to angle F, and those are labeled blue. Okay, I also know that my sides must be the same, so side AB is congruent to side DE. Right? Side BC is congruent to side EF. And side AC is congruent to side DF. Okay, all of this, I didn't need my picture to show me, but I got just from this congruent statement. Alright, because of CPCTC, if I know that the triangles are congruent, I know the corresponding parts are congruent. Another theorem is the third angles theorem. Right, and that says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. Right, so if I know two angles in each triangle are congruent, I know the third one has to be congruent too. Right, and we can kind of look at why. If this angle is 83 degrees, right, I know that it corresponds to this one curve, the single curve over here for angle E. So I know that this angle is 83 degrees. Right, 83 and 42 plus this angle F over here has got to give me 180. So if I subtract those from 180, I get 55. So angle F has to be 55. Well, if I look at triangle ABC, I have this double curve over here, which tells me that it's congruent to angle D, which is 42 degrees. So if I put a 42 over here, and again subtract them from 180, I'm left with 55 degrees for my third angle. So if I know any two angles are congruent, I know the third one has to be congruent too. Now we're going to look at congruence postulates. The first one is side, side, side. All right, these are going to help us prove that our triangles are congruent. Okay, so if we can figure out one of these congruence postulates, if we can prove it somehow, then we can then prove the triangles are congruent. So side, side, side is a really easy one, right? And it just says if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So if we can figure out how to prove that the three sides are the same, then we know the triangles are the same. All right, so if we look here, right, I've got AB is congruent to DE, AC is congruent to DF, and BC is congruent to FE. All right, so I have all three of my sides are the same, so I can write my congruent statement saying that triangle ABC is congruent to triangle. Now I have to line up my letters, right? I see that AB is congruent to DE, so I've got to start with DE, and then I can put my F because EF is congruent to BC. All right, so triangle ABC is congruent to triangle DEF. We can look tomorrow in class a little closer at why this congruence postulate works. Okay, we do not have to say side, side, side every time. We can just say SSS. So if we prove it to be congruent from side, 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 it's congruent because of SSS. The second we're going to look at tonight is side, angle, side. Okay, now with side, 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 order didn't matter because it was all sides, all S's. Here with this angle in the middle, order matters, right? So we have SAS, and it says if two sides and the included angle, that's important, of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent, right? This included angle is very important. An included angle is the angle formed by two adjacent sides of a polygon. Okay, so the included angle is the one that's touching both of those sides. So up here, just like the A is in the middle of the two S's, it's touching both S's. The angle in our triangle has to touch both sides. So if we look down here, we've got this angle E and angle B that are congruent, and then AB and DE are congruent, and BC and FE are congruent. Okay, so this angle B is touching both of the sides that we know are congruent, so it is an included angle. If it were angle A, we wouldn't be able to tell anything because it's not touching both angles. This is a non-included angle, right? So we need the included angle. Right now I can line up my vertices to make my congruent statement, right? I know that B is congruent to E, so that's got to be lined up. And I know that AB is congruent to DE, so I've got to start with a DE and an F. Right, so my angle B and angle E are both in the middle, and I know those are congruent, and then I can line up the rest. And that is it for this video.